Okay, hi once again everyone. It's Professor Sebastian returning to our Calculus 3 class notes. We're on the last of 3 pages in section 14.1. And on this page we want to talk about graphs, level curves, and contours of functions of two variables. So definitions. Level curve of a function f. That's the set of points in the plane where a function f of xy has a constant value. F of xy equals c. The graph of f is the set of all points x, y, z in space such that x, y is in the domain of f. That's more commonly known as the surface z equals f of x, y. So a function of two variables when graphed in 3 space is actually a surface in 3 space. So for example 39, let's say we want to graph f of x, y equals 100 minus x squared minus y squared and then plot the level curves f of xy equals the constant 0, f of xy equals the constant 51, and f of xy equals the constant 75. Okay, so what does that mean? So first of all, let's look at the function f of xy equals 100 minus x squared minus y squared. So this is an upside down paraboloid. So just like this upside down bowl looking shape. When x and y are both 0, it has an apex up here at z equals 100. So in the x direction, it's the upside down parabola, 100 minus x squared, crosses the x-axis at 10 and minus 10. And in the y direction, the same thing. It's the upside down parabola, 100 minus y squared, crosses the y-axis at minus 10 and 10. So you can visualize that upside down paraboloid. Now what are the level curves? So the level curves are, you imagine taking a slice of this guy. So we're going to take a slice at it at a height of z equals 0 first, right? The constant is 0. So at z equals 0, we take a slice. So in other words, it's just this circle down here on the xy plane, radius 10. So that's the first level curve, and I labeled it as c equals 0 to correspond to f of xy equals a constant. That's the case if constant equals 0. So I strategically chose these so these would all end up to be circles of a radius that were easy for me to draw for you. But if I then cut this, if I like take a slice of this, imagine slicing a plane parallel to the xy plane straight through this, and that would form a circle. So at a height of z equals 51, right about in here, I slice it. So when I plug in 51 for z, or f of xy, I get 51 equals 100 minus x squared minus y squared. So you subtract 100, you get minus 49 equals minus x squared minus y squared. In other words, it's the circle x squared plus y squared equals 49. It's a circle centered at 0, 0, radius of 7. So that's this circle right here. And so that's the level curve of our upside down paraboloid corresponding to the constant c equals 51. And similarly for the constant c equals 75, you set f of xy equals 75. Plug it in here, you see that that's the circle x squared plus y squared equals 25. So that's a circle of radius 5. So I cut it at 51, I cut it at 75, and you can see these level curves are closer to each other, which is indicating there's a steepness. You can see a steepness over here. It's like, imagine this is a mountain. It's steeper here than it is down here. So their level curves are not as close together here. So it's not as steep in this area as it is in the area between these two level curves. Now functions of 3 variables, since the graphs of functions of 3 variables consist of the points x, y, z, and w lying in 4-dimensional space, we cannot sketch them in our multi-dimensional frame of reference. So what are we going to do? Well, we can't look at the actual function of 3 variables, w equals f of x, y, z, because that exists in 4 dimensions. But what we can do is look at the level contours, or the contours of that function of 3 variables, which then brings it down 1 dimension. And those are called level surfaces. So you can imagine that here we have a function of 3 variables. This is like w equals f of x, y, z. So w equals x squared plus y squared plus z squared under the square root. This is one we talked about the domain of. Okay, well, for any constant I plug in for w, the level surfaces are these guys, x squared plus y squared plus z squared under the square root equals c. If I were to square both sides, that's an entire sphere. But if I'm looking at the positive square root, that's the upper half of the sphere of radius c. So you can imagine it's like those shell games where you put one shell inside of another. You have your one level surface. So when c is equal to 10, I'm sorry, c equals 3, you have if I were to square it, it would be a sphere of radius 3, right, all the way around, but I only have the upper half sphere. If c equals 2, that would be a sphere of radius 2 all the way around, but I only have the upper half sphere. And if c equals 1, that's a sphere of radius 1 inside this guy, which is inside this guy. So you see these level surfaces instead. And we've talked about, I've showed you some things in class, but just remember that GeoGebra 3D is a very good free online tool for 3D graphing. So go ahead and play with it a bit as you're working on your homework if you're having a hard time visualizing the surfaces or their level curves.